You know, there's this idea that's almost become law in the developer world. Cross-platform apps just can't keep up with native ones when it comes to performance. Well, today, we're going to challenge that. We're going to dive into how a really smart, multi-layered approach to architecture can lead to some seriously extreme optimization. So, let's just get right to it. Is native really always the fastest? For years, the deal was simple, right? You use a cross-platform tool to build faster, but you take a performance hit. But what if that's just not true anymore? What if, with the right engineering, you could build something that doesn't just match native performance, but actually beats it? To figure that out, we first need to meet the villains we're up against.
First on our list is lag. This is pretty straightforward. It's the delay between you tapping something and the app actually doing something. Once that delay gets longer than about 100 milliseconds, our brains pick up on it and the app just feels slow.
Then there's jank. Oh, jank is the absolute enemy of smooth, buttery animations. See, for a silky smooth 60 frames per second, your app has just 16.6 milliseconds to draw every single frame. If it misses that deadline even by a little bit, a frame gets dropped, and what you see is a jarring stutter. It's like a song skipping a beat. It just feels wrong.
And finally, we have stuttering. Now, this is a bit different from jank. It's a wider problem, an overall inconsistency in how the frames are getting to the screen. And a lot of the time, the bad guy isn't your graphics code. It's something else, like the system trying to clean up memory in the background, what we call garbage collection, which suddenly freezes the main thread and makes everything grind to a halt.
Okay, so how do we take on these three performance killers? Well, it all starts at the very bottom, with the foundation, the compiler, and the toolchain you're using. You just can't build a race car on a rickety frame.
And here's the thing that's absolutely critical. Your tools have to be perfectly in sync with the operating system you're building for. Take Delphi 12.3, for example. It's built to align directly with Google's latest rules for Android 15, supporting its newest SDK and NDK. And this isn't just about getting new features. It's about making sure the very core of your app works the way the OS is designed to work.
Now, this is where it gets really interesting. It's a small change with a huge impact. Modern Android phones running 64-bit processors now want to work with 16-kilobyte chunks of memory instead of the old 4-kilobyte standard. By using a tool chain that knows this, you cut down on the work the OS has to do to manage memory. And what's the result? Faster app startups and less of that system-wide stutter. And this number? That's a 15% speed boost in the Delphi 12.3 compiler itself. Now, you might think, okay, faster builds are nice for me, the developer, but it's more than that. When you can build and test your app faster, it means you can run performance checks way more often. You can find and fix those little things that cause jank long before your users ever see them. All right, our foundation is solid. Now let's head down to the engine room. If we really want this app to fly, we have to talk about the GPU and a total game changer in how graphics get drawn on the screen. So, the old way of doing things involved using different graphics backends for different platforms. It worked, but it was complex and could lead to weird inconsistencies. The new way? It unifies everything under one single, massively optimized engine, Google's Skia graphics library. And listen, this is a huge deal. Skia is not some small niche library. It is the battle-tested, hardcore graphics engine that powers some of the biggest software on the planet, including Google Chrome and Android itself. This thing is built from the ground up for speed and quality.
And the proof is right here. This benchmark, run on a real-world phone, shows an incredible jump in performance. Just by flipping the switch to use Skia as the renderer, the frame rate went from a pretty choppy 25 frames per second to a much smoother 38. That's a night-and-day difference in user experience, just from changing the engine.
Oh, but it gets even better. On Android devices that support it, Skia can use what's called the Vulkan backend. Think of Vulkan as a direct high-speed lane to the GPU. It cuts out the middleman, which means the CPU does less work. That translates to less battery drain, less heat, and it stops your phone from slowing down when it gets hot. You know, that dreaded thermal throttle. Okay, we've supercharged the GPU. Now we need to talk about the CPU. Because, honestly, the number one reason an app feels frozen has nothing to do with graphics. It's all about a blocked main thread.
This is like the first commandment of Android development. The main UI thread is sacred. It's the only thread that can touch the user interface. If you make it busy with a heavy task for more than 5 seconds, Android's operating system just gives up. It assumes your app is broken and kills it, throwing up that horrible application not responding message.
And the path to getting your app killed is so simple it's scary. First,
You run a long task on that main UI thread. Second, because that thread is busy, it can't respond to the user's taps, so the entire UI freezes solid. Third, if it stays frozen too long, the OS steps in and pulls the plug. Game over.
So what kind of tasks are we talking about here? Well, it's pretty much anything that you can't guarantee will finish instantly. Making a network request, talking to a database, reading a big file from disk, or chewing through a huge chunk of JSON data. All of these must be moved to a background thread. Period. No exceptions. It's the only way to keep your UI alive and responsive.
All right, on to our final layer of optimization. This is all about the smart choices you can make with your UI components and how you manage memory. These are the areas where tiny changes can lead to massive wins. Here is a perfect example. Let's say you need to show a really long list of items. If you use a component like a T-list box, you're setting yourself up for a performance nightmare. Why? Because it creates a full, heavy-duty component for every single item in the list, even the ones you can't see. But something like a T-list view is way faster because it's smart. It only creates the visual bits for the items that are actually on the screen right now.
This quote really hits on a core advantage: memory management. See, unlike a lot of languages that use automatic garbage collection that can randomly pause your app to clean up memory, Delphi gives the developer direct control. And when you do it right, you get apps that are incredibly efficient because you completely avoid that performance tax from the garbage collector.
So to wrap this up, here are a few more quick tips that have a huge impact. Keep your UI layouts as flat and simple as possible. It makes them way faster to draw. Go easy on expensive visual effects like shadows and blurs. And finally, practice lazy loading. Don't create parts of your UI until the very moment the user actually needs to see them.
So let's step back. When you take all of these pieces, the modern toolchain, the supercharged GPU pipeline, the smart threading, the efficient UI choices, what do you actually have? You have a system where high performance isn't just a happy accident. It's the direct result of deliberate, careful engineering at every single level. And this is what's possible. By plugging in an engine like Skia, you could see a graphics throughput boost of over 50%. We're not just talking about keeping up with native anymore. We're talking about building a graphics pipeline that can be fundamentally more performant.
Which brings us all the way back to that first question we asked. If jaw-dropping performance really comes from architecture and your toolchain and smart engineering, not just the language you started with, then what does the word native even mean anymore when we talk about speed? Maybe it's not about where you start. Maybe it's about how well you engineer the journey.